This is Mr. Anderson for Kellogg Community College. We're looking at Math 121 Intermediate Algebra, Chapter 3, Section 4, Systems of Equations in 3 Variables. With 3 variables, we need 3 equations to solve. Now, I would strongly suggest that you go to the book and take a look at some of the examples in the book, because they have some pretty cool physical renderings of the planes in interacting with each other in 3 dimensions, and that will give you a much better idea of what we're actually looking for here, because with 3 equations and 3 unknowns, we're hoping that they intersect at a point, and at those points we are going to get one solution. Well, what we're going to do first is take a look and see if there's easy things to eliminate. Like we did in the previous section here, we're going to look to see if there are opposites, maybe like you see where these y's are opposites and these z's are opposites. So by putting these opposites together, what we're going to do is try to get some elimination steps going. So with the y's and z's kind of perfectly set up there, what we're going to do is put these two together and add them together. X plus 2x makes a total of 3x. Y minus y is 0, negative z plus z is 0, and 0 plus 3 is 3. So what I get here is I get x is equal to 1. So I actually have one of my 3 solutions right there, which is pretty nice. I can plug my 1 back into these top 2 equations here, but that won't actually get me further. Once you've worked on putting 2 equations together, try putting 2 other equations together, like maybe these bottom 2 right here, and see what happens when you try to do some work on them. Now, since we actually already know what the x value is equal to, we can plug them into these 2 equations and see what we get. So I'm going to rewrite this equation with a 1 instead of x. So this becomes 2 times 1 minus y plus z is equal to 3. That gives me 2 minus y plus z is equal to 3, which gives me, if I subtract 2 from both sides, sorry, that doesn't look like a 2. This gives me negative y plus z is equal to 1. Now that's going to be my first equation. Notice that x is gone. So now I'm just going to look at taking my bottom equation and plugging 1 in for that x as well. There we go, negative 1. 1 times the negative there, plus 5y minus 3z is equal to 2. So I've got 5y minus 3z, and I'm going to add the 1 to both sides, is equal to 3. So there are my 2 equations. My 2 equations now with x eliminated, because we already know that x is equal to 1, we can now stack these together. Now what I'm going to do is I'm going to multiply this equation here on the left by 5. And I can multiply that by 5 because that is going to give me opposite y's. So this gives me a negative 5y plus 5z, which gives me a total of 5 right there. So notice that everything here got multiplied by 5. So these y's go away. This makes a total of positive 2z, and this makes a total of 8. I'm going to divide both sides by 2 now, and z is going to be equal to 4. Alright, so now I know my z and I know my x. All I got to do is solve for y. I'm going to look back at my top equation. That one seems to be the easiest to use. So x, which is my 1, plus y, which we don't know, minus my z, which is going to be 4, is equal to 0. So I'm going to go y, 1 minus 4 is negative 3 is equal to 0. I'm going to add 3 to both sides. Y is equal to positive 3. So now I have a 1, 3, and 4, and I can actually plug that back into each of these equations, 1, 2, and 3, to check and see if they're valid. If I plug that into the first equation, 1 plus 3 minus 4 is 0. Plugging into the second equation, 2 times 1 is 2, minus 3 is negative 1, plus 4 is positive 3. And it goes negative 1 plus 5 times 3, which is 15, minus 12. So negative 1 plus 15 minus 12 is 2. So all of these work, and these three planes actually intersect at a point, which is pretty fun. Alright, so moving on, we're going to take a look at the next problem. So take a deep breath. Let's go on to the next one. Okay, let's go do some combinations to put these together. Okay, so I'm going to look at the first two equations and see if there's something I can easily eliminate. Right now it's not as easy though. You'll see that I've got a negative and a positive. So I'm going to take that second line and I'm going to multiply it by 3. So do this line, multiply it by 3, and that makes my top line x plus y minus 3z is equal to 4. Now the line below it. Multiplying by 3, I now have 6x plus 9y plus 3z equals 18. 6, 12, and 18. Let's add these together. This is going to be 7x plus 10y. The z's go away, is equal to 22. Now that may not have helped too much here, but by putting these top two lines together, I've eliminated the z's. So now what I'm going to do is go and do the same thing with these bottom two lines. Now what I will do is I will take these bottom two lines and multiply by a -1. So I'm going to multiply that by a -1 in the bottom. So that's going to make my top line, I'm going to rewrite this, 2x plus 3y plus z equals 6. And I'm going to have a -2x, which is going to be kind of nice, plus a y to add to my 3y, minus my z equals positive 14. Now check this out. If you see these two simplify, that simplifies too. That's what I was expecting to happen, but I didn't expect the x's to happen. So now I have 4y is equal to 20. Now what's cool about this is I can divide both sides by 4 and I figure out my y variable. My y variable is 5. And now I can plug that 5 into this equation up here to figure out my x. So the work I did ahead of time was actually pretty good because I can just use my letter right there. So I'm going to go 7x plus 10 times 5, which is 50, equals 22. Oh, I hope this works out to be a nice answer. And I think all the problems on the homework that I'm going to give you are going to be nice answered problems. So this is going to be -28. Look at that. Dividing both sides by 7, x is equal to -4. Fantastic. Now I just have to find one more letter, which is going to be my z. So I just go to any of my equations, my top, middle, or bottom, plug in my x and my y, and I can figure out my z. I think I'm going to choose the middle one. The middle one's nice because it doesn't have any negatives in it. So I'm going to go 2 times -4, and then I'm going to go plus 3 times 5 plus z equals 6. So -8 plus 15 plus z equals 6. All right, -8 and 15 is going to be 7 plus z equals 6. I see where this is going. Subtract 7 on both sides. My answer for z is going to be -1. Ha! So my answer will be -4, 5, -1. These three planes intersect at a point, and I can plug these 3 points back into any of these equations up here and check my answer. All right, time for another deep breath. Whew! And we're going to move on to the next problem. All right, on this third problem, something very interesting is going to happen here. When we try to eliminate some letters, you're going to see some interesting things happen to this equation. Take a look at the top and the middle plane. Now you'll notice that the y's are already opposite, so all I need to do is take this first plane and multiply by 2. And if I multiply by 2, I get 2x minus 2y plus 2z. Ah, there I did it again. I want that to look like a 2, not zz, is equal to 8. Then I'm going to multiply this line by 1, so it stays the same, 5x plus 2y minus, I put plus, but I'll put -3z to cover that up, is equal to 2. Alright, so let's put these together. 5 and 2 makes 7x, these simplify to 0, this makes a -z, and this makes a 10. Now, what I'm about to do is I'm going to pick the middle and the bottom, and I'm going to eliminate the y's. And to do so, I'm just going to take my middle line here, break it down, and multiply it by negative 3. And to do that, I get a negative 15x, I get a negative 6y, whoops, didn't write there, negative 6y, I get a positive 9z, and I also get a negative 6. Then what I'm going to do here is take this bottom line and multiply it by positive 2. And this is going to give me an 8x. It's going to give me a positive 6y. So my y's will eliminate. It's going to give me my negative 8z, and it's going to give me a negative 4. Put all these together. This makes negative 7x. This makes a positive z, and then this makes a negative 10. Now I'm going to put these two equations together here and here. So this makes 7x minus z equals 10, and this is negative 7x plus z equals negative 10. If I add these up, I get 0 equals 0. This is a true statement. But when I ever have a true statement and all the variables eliminate, I must be dealing with the same planes written in a different way, and this is called a dependent solution. And it's a dependent solution which will happen once in your homework. If you find your x's and y's all getting eliminated and a true statement evolving, this is a dependent situation where the planes are overlapping each other. All right, let's take another deep breath and move on to the last problem. Another strange situation happens here, so let's go take a look. All right. For this problem, there's going to be something strange that happens here when we try to eliminate things in these planes. But the first thing I'm going to do is maybe analyze them, see which letters we could eliminate. Let's eliminate the y's. So let's take our top equation, multiply it by 3, so it becomes 12x plus 3y plus 3z equals 51. Then take our second line. I'm just going to put here times 3. We're just going to keep this the same, so we're going to multiply it by 1. So this becomes x minus 3y plus 2z equals negative 8. Draw a line and start dropping these out here. We got 13x, these y's go away, plus 5z is equal to 43. All right, so there we have that, and what I'm going to do is now take my equations over here, find another pair, and eliminate the y's. I'm going to take my top equation here. I'm going to use that. I'm going to take that top equation and multiply the top equation by 2. Now this is going all the way to the left here, so kind of track from the very left of the screen to this side right here. 8x plus 2y plus 2z equals 34. Now I'm going to take this equation down at the very bottom and keep that exactly the same. I'm going to multiply that by 1, so I get 5x, that should look like a times 1, not 0.1, minus 2y plus 3z is equal to 5. Alright, great. Draw a line there. So I add these up. This is going to be 13x. These simplify to 0. This makes 5z. And this here makes 34 plus 5, which is 39. I'm going to combine these two equations together. I'm going to stack them on top of each other. So I'm going to bring this over here and say 13x plus 5z equals 39. Uh-oh, we have a problem here, guys, because if I multiply this by a negative 1, which will change all of these to a negative symbol, and add, those get eliminated for 0, and this doesn't get eliminated to a 0. That 39 from 43 gives me a non-zero. That's not true. Therefore, there's no solution here. And what means is that you're going to have some parallel planes in this situation. These planes are parallel in 3 dimensions, so they have no solution. When you run into an illogical statement like this, that is your answer. This is a section that you're definitely going to need to get in, get dirty, and definitely play a little bit. I'm also going to show you in a separate video how to do stuff like this on the matrices, so you can maybe give yourself a little bit of a hand with the graphing calculator. Well, thanks for watching.